Welcome to the deep dive. We sift through the complex reports, the dense data, so you get the core insights you need.
And today, yeah, we're tackling a big one. An image that's, well, almost become a cliche in economics coverage lately.
The dark factory, that picture of a totally automated warehouse, robots gliding around in the dark, no humans in sight.
Right, that's the image often pushed as, the inevitable future of making things. But when you actually dig into the data, and we have a really comprehensive set here.
Yeah, what are we working with today?
We've pulled together analysis covering roughly 2018 right through to mid-2025. Plus, it looks forward, projecting into the post-2030 era, which is when artificial general intelligence, or AGI, is expected to really start converging with robotics.
Okay, so a solid time frame. And the picture emerging from that data is...
It's much more complicated.
Okay.
Honestly, way more interesting than just robots take all the jobs.
So our mission today is to get beyond that simple story. We want to understand how this wave of automation, this advanced AI, is genuinely reshaping manufacturing work across the globe.
And crucially, why it looks so different depending on where you are. The technology might be similar, but the impact, it's heavily shaped by national circumstances.
Which leads to the core idea we want you, the listener, to really grasp today.
Yeah, it's less about jobs simply vanishing. The report we're drawing on calls it the great retasking. That feels right.
Retasking, meaning the nature of the work itself is changing.
Profoundly. We're seeing a huge shift. Industrial jobs are moving away from, say, the repetitive manual tasks we associate with the 20th century assembly line,
Right.
toward skills that look a lot more like white-collar work, but happening right there on the factory floor. Technical skills, analytical thinking, diagnostics. It's really the birth, or maybe the acceleration, of this new-collar workforce.
Okay, new collar. I like that. And we'll explore what drives that. You mentioned different national pressures.
Exactly. We'll look at why the U.S. seems to be using automation, almost like an anti-retirement plan, why China sees it more like a strategic weapon, and, well, how Japan's situation is different again.
Plus, the big one, AGI. How does that potentially change the game entirely? And this idea of a massive multi-trillion-dollar divide it might create.
Yeah, the economics of AGI deployment are daunting. Well, let's just say it gets really fascinating and maybe a little concerning when you look past the current tech.
All right, let's dive in. Okay, let's properly define this dark factory concept first, the sort of theoretical ideal. What does that actually involve tech-wise?
Right, so lights out manufacturing, the dark factory. It's the peak vision of what people call Industry 4.0.
Industry 4.0, okay.
Yeah. You're imagining a facility that runs, 24/7, completely autonomously, everything connected, high-speed local networks, probably 5G now, managing the entire workflow.
And the dark part is literal.
Pretty much. If there are absolutely no humans on the floor, you don't need lights, you don't need heating or ventilation, not in the same way anyway. Big savings on operating costs, right? OpEx.
Makes sense. And the tech enabling this.
It's a whole suite of things. Industrial robots, obviously, but also AI-driven machine vision for quality control, maybe. And crucially, the IIoT.
IIoT, Industrial Internet of Things.
Exactly. Think sensors embedded everywhere in all the machines, constantly feeding data back to a central system, coordinating everything.
Okay, so it sounds incredibly efficient. High setup costs maybe, but low running costs. An accountant's fantasy, like you said.
Pretty much.
So why then, in this period we're looking at, 2018 to 2025, are these fully dark factories still so incredibly rare, especially in places like the US and Europe, if the tech exists?
Well, that's where the ideal bumps up against the messy reality of actually making things.
How so?
The data suggests that the fully dark lights out model really only works smoothly for very specific scenarios. Think high volume production of something really simple, really standardized.
Like basic components, or maybe bulk chemicals.
Exactly. Things that are always the same, churned out in massive quantities. The moment you introduce complexity or variation, or you need to switch product lines quickly,
The system struggles.
it really does. Because complexity means things aren't always predictable. Maybe a part isn't perfectly aligned or a sensor gives a weird reading. Current automation, the pre-AGI kind, is pretty bad at handling novelty or ambiguity.
Right, it's programmed for specific tasks.
Precisely. And trying to automate every possible exception, every edge case, the cost of that, the capital expenditure, the CapEx, it just skyrockets.
Right.
For most companies, the return on investment, the ROI, just isn't there for full automation.
Okay, so the dark factory is the dream, the ceiling. What's the reality? What's the model that is actually being widely adopted right now?
The dominant model is what the report called the light sparse factory.
Light sparse, so not totally dark.
Not at all. Think of it more like islands of automation within the factory. You'll have specific zones or processes that are highly automated.
Like what kinds of processes?
Things that are very precise and repeatable. CNC machining, that's computer numerical control milling and lathing.
Right.
Automated welding stations, injection molding. These are perfect candidates.
So in those areas, maybe the lights are dimmed or off during certain shifts.
Yeah, possibly. But the key point is, the entire facility isn't running autonomously 24/7. There are still people, crucial people.
And this shift in thinking from aiming for 100% replacement to this more targeted task-based automation, that must completely change the role of the humans who are still there, right?
Absolutely. It's a fundamental shift. Humans aren't being eliminated. In many ways, their roles are becoming more critical, just different.
How so? What are they doing?
They're handling the tasks that demand flexibility or complex problem solving, or that fine-tuned dexterity that robots, well, frankly, still struggle with.
Give me some examples.
Okay, number one is often setup. Setting up those complex CNC machines or assembly lines for a new product run. That takes skill. Then removing finished parts, especially if it's a custom or complex product.
What about quality? I thought AI vision systems were getting good at that.
They are, for basic pass-fail checks on standardized items. But for complex assemblies or looking for subtle defects or making subjective judgments about quality on, say, a bespoke piece of furniture, human eyes and judgment are still often superior.
Okay.
And then there are two huge ones: programming and optimization. Teaching the robots new tasks, refining their movements, making the whole system more efficient. That requires skilled programmers.
And the second big one?
Maintenance. When one part of this highly integrated automated system goes down, it can halt everything. You don't just need someone to swap a part. You need a highly skilled technician who understands the mechanics, the electronics, and the software to diagnose and fix it quickly. These aren't low-skilled jobs.
So that distinction is key then. Current automation focuses on tasks within a job, not necessarily the entire job itself.
Exactly. It leads to job transformation, requiring new skills rather than simple job elimination.
And that really sets the stage for this whole great retasking idea.
It's the absolute foundation.
Yeah.
We're not seeing, one robot replacing one worker in a simple swap. We're seeing the routine, predictable parts of many jobs getting automated.
Which forces the human worker to adapt.
Right. They need to develop the skills to manage, maintain, or work alongside the automation. They need to become more digital, more analytical. It pushes the job up the value chain, you could say.
And if companies don't invest in training their existing workforce for these new tasks?
Then they just end up with a skills gap. They have a vacancy they can't fill even if they wanted to hire. The need for the work hasn't gone away, just the nature of how it gets done.
Okay, let's get into that variation you mentioned. Why the same robot might have a totally different impact in, say, the US versus China versus Japan.
This is really the core argument we extracted. The impact isn't inherent in the tech itself. It's dictated by what we're calling the distinct national driver in each of the big three manufacturing economies.
And those big three, by output, are China way out front at around $4.66 trillion, then the U.S. at $2.91 trillion, and Japan at $867 billion, roughly.
Correct. And in each one, automation is being deployed to solve a very different, very specific, deep-seated national challenge. It's not a one-size-fits-all solution.
Let's start stateside. The U.S. situation seems like a real paradox right now. You've got government policy, like the GHTS Act, the Inflation Reduction Act, trying to boost manufacturing, bring production back.
A policy-driven jobs boom, in theory. Reshoring is happening. New factories are being built or planned.
But at the same time, the manufacturing sector is facing a massive labor shortage. It's almost like a demographic time bomb.
It really is. The numbers are stark. And this isn't just a temporary blip. The sources indicate that around mid-2025, there was something like 415,000 unfilled manufacturing jobs in the U.S.
Wow, nearly 500,000.
Yeah. But the bigger issue is long-term. Demographics. Look at the workforce. About 26% of current manufacturing workers, that's almost 4 million people, are 55 or older.
Meaning they're heading towards retirement relatively soon.
Exactly. Taking decades of experience and know-how with them. And the pipeline of younger workers coming in isn't filling that gap fast enough.
What are the projections looking like?
The National Association of Manufacturers estimates that by 2033, as many as 1.9 million manufacturing jobs could go unfilled simply due to this retirement wave and the skills mismatch. That's a huge potential brake on growth.
And meanwhile, the overall labor market is tight.
Very tight. Unemployment around 4.2% nationally as the data we reviewed. So companies building these new factories or expanding existing ones because of reshoring incentives, they literally cannot find enough people to staff them.
So suddenly, automation in the U.S. context takes on a completely different role. It's not about cutting costs by firing people.
Not primarily, no. It's become a necessity driven by scarcity. It's a patch, as the report calls it, on this demographic hole. Companies aren't automating to replace Jane or Joe on the line. They're automating because Jane and Joe are retiring, and there's no one qualified applying for their jobs.
They're using robots to simply meet the production demand that the government policies are trying to stimulate, but that the human workforce physically can't handle.
That's the dynamic. It's automation basically filling in for missing workers, allowing companies to actually operate and fulfill orders.
So what's the net effect been on overall U.S. manufacturing employment numbers? The metric ManMP, right?
Relative stability, which is kind of counterintuitive if you only think of automation as job destruction. ManMP was around 12.7 million, maybe 12.722 million in August 2025, according to the data.
So despite more robots, the total number of human jobs hasn't cratered.
No, and in fact, some research highlighted suggests that at the firm level, AI and automation adoption in the U.S. has often correlated with growth and increased overall employment.
How does that work?
Because the automation allows the company to scale up production, maybe enter new markets, do things they couldn't before because they were labor constrained. That growth then creates new human jobs in areas that aren't easily automated. R&D, sales, marketing, logistics, higher-level management.
So the robots handle the production bottleneck, enabling the company to grow, which then requires more people in other roles.
Exactly. It acts as a force multiplier for the limited human workforce they do have. It's a defensive strategy, really, using tech to maintain output in the face of worker shortages. Very different from what we see elsewhere.
Okay, let's shift focus to China. You said the driver there is completely different. Not scarcity, but strategy.
Absolutely. In China, the push for automation is top-down. It's a deliberate, state-directed policy. Think Made in China 2025.
Right. That initiative aimed at upgrading their industrial base.
Precisely. The goal is twofold. Achieve global leadership in high-tech manufacturing sectors, and critically reduce China's reliance on foreign technology, especially in areas like robotics and semiconductors. Automation is seen as a key tool, almost a strategic weapon, to achieve those state objectives.
And that strategic push must translate into massive investment and deployment numbers on the ground.
The numbers are, frankly, staggering. The report notes that in 2024, China installed 54% of all new industrial robots globally.
Wait, more than half the world's total?
More than the rest of the world combined in that year. It's an unprecedented rate of adoption. They have this explicit target, I think it was reaching 500 robots per 10,000 manufacturing workers by 2025. That's incredibly robot dense.
Can you give us a concrete example of what this looks like in a Chinese factory?
Sure. The report highlights a couple of striking cases. Xiaomi, the big electronics firm, built a factory in Changping. Cost something like $330 million.
Okay. What does it make?
Smartphones. And the key thing, it reportedly produces one phone every 3 seconds, with essentially 0 human workers directly involved on the main production floor, fully automated.
Wow. And other examples?
Gree Electric, another giant, transformed one of its plants into what they claim is the world's largest lights-out factory running on advanced 5.5G networks. They reported an 86% efficiency boost. These aren't isolated experiments. They represent the direction state policy is pushing: maximum productivity, minimum human labor costs where possible.
But surely this incredibly rapid state-fueled automation drive must have significant consequences for the workforce, especially the lower-skilled workers who formed the backbone of China's manufacturing boom previously.
Oh, absolutely. This is where we see what the research calls the dual effect very clearly. On one hand, yes, there's massive displacement of lower-skilled routine jobs.
We've heard about Foxconn, for example.
Foxconn is the canary in the coal mine. They replaced, famously, something like 60,000 workers in just one factory complex in Kunshan. And broader estimates suggest they automated away maybe 400,000 jobs across their Chinese operations between 2012 and 2016 alone.
400,000, that's huge.
It is, and quantitative studies confirm this effect. One analysis showed that for workers in industries with higher robot exposure, even a standard measure of increased exposure led to about a 5% lower probability of being employed. So displacement is real and significant.
So that's one side of the dual effect. What's the other side?
The other side is polarization and scale. While low-skilled jobs get substituted away, the demand for high-skilled workers skyrockets.
The people who design, program, manage, and maintain these advanced systems.
Exactly. The engineers, the data scientists, the robotics specialists. The data shows a very strong positive link between automation adoption in China and rising wages for these high-skilled groups. The correlation coefficient, R value, was cited as 0.96, which is incredibly high.
Okay, so demand for top talent goes up. What about overall job numbers at these automating firms?
This is the counterintuitive part. Because these firms become so much more productive, they often capture huge chunks of market share, both domestically and globally. This expansion effect means that many robot-adopting firms in China actually increase their total headcount.
Even though they're automating production jobs?
Yes, one study estimated an average increase of around 11.6% in total employment. Because while they cut shop floor labor, they need significantly more people in R&D, product design, global logistics, marketing roles that support the expanded scale and aren't easily automated yet.
So China's strategy is effectively sacrificing millions of low-skill, low-wage jobs now in exchange for potentially dominating high-tech, high-value industries later.
That seems to be the long-term calculation. It's a ruthless pursuit of competitive advantage, using automation as a primary lever, accepting the social disruption as a necessary cost.
All right, let's complete the triangle and look at Japan. Here, the driver shifts again. Not scarcity like the U.S., not strategy like China, but necessity, demographic imperative.
Precisely. Japan's situation is defined by its population dynamics. It has one of the oldest populations and lowest birth rates in the world. This creates severe chronic labor shortages across the economy, especially in manufacturing. Their unemployment rate is incredibly low, around 2.5% in the period studied.
So they literally don't have enough working-age people.
Especially in that crucial middle-aged cohort that traditionally dominates manufacturing roles. Research shows a clear pattern in advanced economies like Japan, Germany, South Korea. The older the workforce, the higher the robot density tends to be. Because automation becomes the only way for many companies to maintain production levels. They adopt robots, primarily to substitute for the workers who simply aren't there. Without automation, many Japanese manufacturers would likely have to drastically shrink, move operations overseas, or even shut down entirely. It's an economic lifeline.
And Japan has always been a leader in robotics technology itself, right?
Absolutely. They're pioneers. Think of Fei-Nuc, the company famous for its dark factories where robots build other robots, reportedly running unsupervised for weeks, up to 30 days sometimes.
So they have the tech expertise.
They do. And crucially, they're also a major supplier of robots to the world. Something like 47% of the world's industrial robots are manufactured in Japan. That gives them a deep industrial ecosystem and maturity in applying the technology.
Okay, so they're pioneers, they have labor shortages. You might expect, based on the Chinese example maybe, that this would lead to job losses as robots fill the gaps. But the outcome looks more like the U.S. stable employment.
That's right. And the reason is that in Japan's context, automation and human labor are acting primarily as complements, not substitutes.
How so? Explain that complementarity.
The robots are predominantly doing tasks for which there are literally no available human workers. By filling those gaps, the automation allows the factories to keep running, to remain viable businesses.
So it preserves the other jobs in the company.
Exactly. It saves the higher value human roles, the engineers, the designers, the managers, the R&D staff, whose jobs would disappear if the factory itself had to close due to lack of production workers. Automation isn't taking jobs. It's helping to preserve the overall enterprise.
So we were seeing Japanese manufacturers still hiring.
Yes, the data indicated they were still adding to payrolls in mid-2025, mostly in those skilled technical oversight and R&D functions. The demand for those complementary roles remains strong.
It's quite telling that even international bodies see it this way.
Yeah, the IMF actually published analysis suggesting Japan needs even more AI and automation just to offset its demographic decline and maintain its standard of living, its GDP per capita. It's seen as essential.
It's really striking when you lay it out like that. The same technology, an industrial robot deployed in 3 major economies for fundamentally different reasons. Patching worker shortages in the U.S., driving strategic dominance in China, and ensuring sheer economic survival in Japan.
It completely dismantles any simplistic, universal narrative about automation just destroying jobs. Context is everything.
Okay, we've mapped the current light-sparse landscape and its limitations. Humans are still needed when things get complex, unpredictable, or require customization.
Right, that's the barrier for current automation. It's good at repetition, bad at novelty.
But the report signals a major shift coming, probably post-2030, driven by the convergence of robotics with artificial general intelligence, AGI. You mentioned this is where the complexity barrier might really fall.
AGI is potentially the game changer. Remember, current AI is narrow. It's trained for specific tasks. AGI implies something different. Human-level cognitive abilities. Reasoning, learning, adapting to unforeseen situations.
So how would equipping a robot with AGI overcome those current limitations on the factory floor?
Well, think about it. An AGI-powered robot wouldn't just be executing pre-programmed instructions. It could potentially understand the entire production process.
Understand it how?
It could monitor everything in real time, make its own decisions about optimizing material flow, energy use, maybe even predict and preempt potential failures. And critically, it could handle variability.
Meaning it could deal with parts that aren't perfectly presented or figure out how to assemble something slightly different from the last unit?
That's the potential, yes. The report talks about embodied agents, AGI giving robots the ability to learn and adapt in the physical world. This is crucial for achieving true mass customization.
The lot size of one idea, making unique products affordably.
Exactly. An AGI system could theoretically reconfigure a production line almost instantly for a completely new product design without extensive human reprogramming. That's the holy grail.
So AGI enables robots to handle exceptions, learn on the fly, basically making the whole factory potentially automatable, not just specific tasks.
That's the profound implication. And we know the big AI labs are working towards this. OpenAI, for example, has explicitly stated that robotics is a key area for actually testing and developing AGI. They need embodied agents to see if their AI can truly understand and interact with the physical world.
So the convergence is actively being pursued.
Very actively. When AGI can master flexible manipulation, perform its own complex quality checks using learned data, and adapt to variations. Yeah, the light sparse model, constrained by complexity, could become obsolete pretty quickly in certain sectors.
Okay, but that sounds incredibly expensive. Building robots with that level of physical dexterity and embedding AGI-level intelligence. The report flags some major economic hurdles here.
Two massive ones, yeah. And they could seriously limit who actually benefits from this AGI revolution.
What's the first hurdle?
Just the sheer capital expenditure, CapEx, required for the underlying infrastructure. We're not talking about just buying some new robots. AGI demands computational power on a scale we've never seen before.
What kind of scale are we talking?
The report cites estimates suggesting global demand for AI might necessitate something like $6.7 trillion in new data center investment by 2030.
6.7 trillion! That's an almost unimaginable number. What's driving that cost?
It's the specialized hardware. Massive amounts of high-end GPUs, new types of AI accelerator chips. Is the energy needed to power them, the cooling systems, the land, the complex global supply chains for all these components. Just the big U.S. tech giants are projected to spend maybe $350 billion on CapEx in 2025 alone, much of it AI-related.
And that's just the build-out cost. What about actually running the AI models?
That's another cost factor, the inference cost. The cost of actually using the trained AGI model to make decisions in real time is still very high, especially for applications like manufacturing where margins can be thin.
Okay, so astronomical CapEx is hurdle number one. What's hurdle number two?
It flows directly from the first,
Right.
the ROI deficit, return on investment.
Meaning companies are spending all this money but not seeing the payoff yet.
Largely, yes. An MIT analysis mentioned in the sources found that something like 95% of companies investing heavily in AI weren't yet seeing significant financial returns.
95%.
Yeah. One estimate, I think, from Sequoia Capital called it a $500 billion hole, the gap between massive AI infrastructure spending and actual measurable productivity gains flowing back to the companies.
That sounds unsustainable for most businesses.
It absolutely is, especially outside of the tech giants who have other revenue streams. The productivity benefits of AI seem concentrated in a few areas so far, while the costs are immediate and enormous. This just doesn't pencil out for a typical manufacturing firm focused on operational efficiency.
And this combination of sky-high costs and uncertain returns leads to a really worrying potential outcome flagged in the report, the AGI divide.
This could be the defining economic challenge of the next decade. It's a potential bifurcation of the entire manufacturing landscape.
Oh, so?
Think about small and medium-sized enterprises, SMEs. They're the backbone of manufacturing in most countries, right? Often 60% or more of employment. They simply do not have the billions, let alone trillions, needed to build or access this kind of AGI infrastructure.
So they get left behind.
That's the risk. You could end up with a two-tiered economy. On one tier, a handful of giant, hyper-productive, fully autonomous companies, maybe the Teslas, the Amazons, the huge conglomerates like Foxconn who can afford the AGI leap.
And on the other tier?
A vast ecosystem of traditional, light, sparse firms, including most SMEs, who just can't compete on cost, speed, or customization anymore. This could lead to massive market consolidation and crush smaller innovators.
So the promise of AGI is this incredible productivity leap, but the economic reality might be increased inequality and oligopoly.
That's the tension. And it forces a fundamental choice on companies and policymakers. The report frames it as choosing between two approaches to automation.
Which are?
Level 0, replacement. This is the purely cost-focused approach. Use AGI and robots simply to eliminate human labor, cut costs, maximize efficiency at any price.
Okay, the ruthless efficiency model, what's the alternative?
Level 1, complementarity or performance-driven. This aligns more with the emerging concept of Industry 5.0 or socially responsible automation.
Industry 5.0, what's the philosophy there?
It reframes the goal. Instead of just replacing humans, it focuses on symbiosis. How can intelligent machines augment human capabilities? How can we design systems where humans and AGI collaborate?
So the most profitable factory of the future might not be the one with 0 humans.
Exactly. It might be one run by a smaller but incredibly skilled human crew who leverage AGI to do things neither could do alone. Handling complex oversight, creative problem solving, managing the overall strategy, while the AGI handles the execution.
It becomes an ethical and strategic choice then. Automate purely to displace or automate to empower and collaborate.
That's the crux of it. And the AGI divide makes that choice incredibly stark.
Okay, let's bring this back down to the impact on actual jobs and workers. We've established traditional manufacturing tasks, the repetitive manual stuff, are definitely declining, and AGI might accelerate that.
Yes, that trend seems clear.
But you're arguing it's a great retasking, a transformation, not just a collapse. How is this new workforce structure defined?
It really boils down to that principle we touched on earlier. Are you a complement to automation or a substitute for it?
Explain that distinction again.
If your job primarily involves tasks that are routine, predictable, easily broken down into steps that software or a robot can replicate, then you're essentially a substitute. Automation can likely do that job, maybe cheaper or faster. Those roles face pressure displacement or wage stagnation.
Okay, that's the substitute side. What about the complement side?
If your job involved tasks that leverage the automation, tasks that the machines enable but can't do themselves, then you're a complement.
Like what kind of tasks?
Managing the automated systems, diagnosing problems when they arise, programming the robots, telling them what to do, integrating the AI with the physical hardware, designing the products the robots will make. These roles are enhanced by automation, not replaced, and they will be in high demand, likely with rising pay.
And this is where the new-collar workforce comes in, these complement roles.
Exactly. The term captures it well. These jobs are often located physically in the factory, like traditional blue-collar work. But the required skill set looks much more like white-collar work. Digital literacy, data analysis, critical thinking, problem solving.
Let's get specific. What are some of these key new-collar roles the reports see growing?
Okay, first, let's look at the essential maintenance side. Even advanced robots need upkeep. The U.S. Bureau of Labor Statistics, for instance, projects strong growth for industrial machinery mechanics and millwrights.
How strong?
Around 15% growth projected between 2023 and 2033. That translates to about 53,000 job openings every year in the U.S. alone. These are the people installing, maintaining, and repairing the complex robotic systems on the factory floor.
Okay, so the hands-on maintenance side is growing. What about roles interacting more directly with the robot's intelligence?
Big demand there too. Robotics technicians. These are often the first responders when a robot glitches. They do troubleshooting, basic programming adjustments, preventative maintenance.
What's the entry point for a job like that? Does it need a full engineering degree?
Not always. This is interesting. Demand is so high that many pathways are opening up. Strong apprenticeship programs, 2-year associate degrees. Starting salaries are often pretty good, maybe $50,000 to $70,000, sometimes more, without the 4-year college debt.
That's significant. Are there entirely new roles emerging specifically because of the AI and AGI integration we discussed?
Definitely. 2 stand out as high-demand, high-wage roles that barely existed a decade ago. First, the AI systems integrator.
What do they do?
They're the crucial link between the complex AI models developed, often in the cloud, and the actual physical machinery on the factory floor.
Yeah.
They make sure the data flows correctly, the AI's decisions get translated into the right robotic actions, and the whole system works together. It's a hybrid hardware-software AI skill set.
Okay, very specialized. And the second new role.
The predictive maintenance technician. This builds on that IIoT concept, the Industrial Internet of Things.
Right, the network of sensors in the machine.
Exactly. These technicians use the data streaming from those sensors, things like vibration patterns, temperature fluctuations, error rates, often combined with the digital twin or virtual model of the factory.
To do what?
To predict when a machine or robot is likely to fail before it actually breaks down. This allows maintenance to be scheduled proactively during planned downtime instead of causing costly emergency shutdowns. It requires data analysis skills alongside mechanical understanding.
So we have maintenance, technicians, integrators, predictive analysts. Are there roles working directly alongside the robots too?
Yes, especially with the rise of cobots, or collaborative robots, which are designed specifically to operate safely near humans. This leads to roles sometimes called cobot operator or robot wrangler.
Robot wrangler, I like that.
Yeah. Their job isn't necessarily deep programming, but managing the workflow between humans and cobots. Maybe loading parts for the cobot, handling tasks the cobot isn't designed for, managing exceptions, ensuring safety and efficiency in that shared workspace. It requires good situational awareness and coordination skills.
Looking at this list, mechanics, technicians, integrators, analysts, operators, the unavoidable conclusion seems to be the jobs are there, or will be there, but they require different skills than the jobs they're replacing.
That's the absolute crux of the issue. It's not primarily a lack of jobs overall that's the problem. It's a fundamental mismatch of skills.
And that mismatch is projected to be severe.
Very. Remember that U.S. projection, potentially 2.1 million unfilled manufacturing jobs by 2030. Not because the jobs don't exist, but because the workforce, both current workers and new entrants from schools, hasn't been trained for these new-collar requirements. The technology is evolving faster than our education and training systems. The World Economic Forum put out a stark figure suggesting maybe 50% of all employees globally would need significant reskilling by the mid-2020s just to stay relevant in their roles due to automation and AI. That's a massive undertaking.
Okay, if the core problem is this massive skills gap, then the ability of a workforce, and indeed a whole country, to adapt and learn new skills, that becomes incredibly valuable.
It becomes the critical asset, more valuable than cheap labor, maybe even more valuable than just having raw materials or capital. Workforce agility, the ability to reskill quickly and effectively, is paramount.
So continuous learning, lifelong reskilling. It's not just a nice-to-have HR initiative anymore. It has to be central.
It has to be a core component of national economic strategy and, frankly, corporate survival strategy, too. The sources strongly suggest that the nation that builds the most efficient and responsive engine for reskilling its people will have a decisive competitive edge this century.
We need to shift focus then. Less about protecting old job titles, more about proactively building the talent needed for the new ones. What do successful models for this look like? Are there countries doing this well?
Singapore is frequently cited as a leader here. Their Skills Future initiative is held up as a gold standard.
Skills Future. What's the approach?
They describe it as a whole-of-nation movement. It's not just a government program. It involves employers, unions, individuals, and crucially, it's proactive. They try to identify job roles likely to be disrupted by technology before mass layoffs happen, and then they heavily incentivize and support workers to retrain for adjacent or future-proof roles.
How do they support workers practically?
One key element is providing every citizen with personal training credits a Skills Future credit account. People can use this money to pay for approved courses, especially those focused on in-demand tech skills like data analytics, AI, advanced manufacturing, robotics. The subsidies can be really significant, sometimes covering up to 90% of the course fees.
So they're making lifelong learning accessible and financially viable for everyone, treating it almost like a public good.
Exactly. It's framed as an economic necessity and a shared responsibility. The goal is to empower individuals to navigate these transitions, moving from being potential substitutes for technology to becoming complements to it. It's about prevention and adaptation, not just reacting after displacement.
What about models in Europe? Anything similar?
Germany's approach, often termed Work 4.0, also emphasizes continuous learning, but perhaps with a stronger focus on integrating it directly into the workplace and focusing on competencies.
How do they do that?
They champion things like competency-based training modules, often developed jointly by industry and education providers. And they're pioneers in using technology for training itself, like augmented reality, AR.
AR for training, how does that work?
Imagine a technician maintaining a complex robot. They wear AR glasses that overlay digital information, like step-by-step instructions, technical diagrams, or sensor readings directly onto their view of the machine. It can dramatically speed up learning and troubleshooting for these complex new systems.
That direct link between the training and the specific needs of employers seems vital to ensure the skills learned are immediately useful. Are we seeing similar partnerships emerge in the U.S.?
Yes, and it's crucial because the traditional path, say a 4-year degree, can often be too slow or too general to meet the rapidly changing needs of industry. Public-private partnerships are key.
Can you give an example?
Ivy Tech Community College in Indiana is a great case study mentioned. They work very closely with major local employers, companies like Siemens, Subaru, and yes, robotics companies like FAE at UC.
How do they work together?
Ivy Tech essentially backward designs its technical degree and certificate programs. They start with the specific skills and credentials the employers say they need right now for their new collar roles and build the curriculum around that.
So graduates walk out with skills they know are in demand and often industry-recognized certifications.
Exactly. They might graduate with a AMN-UC certification alongside their associate degree, making them immediately employable in those high-demand robotics technician or maintenance roles. It bypasses that frustrating gap where graduates have a degree but still need extensive on-the-job training.
And it's not just colleges. Corporations themselves are getting heavily involved in creating their own talent pipelines, aren't they? They can't always wait for the education system.
They really can't afford to wait. The skills gap is too urgent. So you see major companies launching their own robust training programs, often structured as formal apprenticeships. Amazon, for example, has a U.S. Department of Labor registered automation engineer apprenticeship program. Siemens has a long-standing and well-regarded global apprenticeship system, particularly strong in mechatronics, that blend of mechanical, electrical, and computer engineering needed for automation.
And these aren't just internships, they're structured programs.
Right. They typically combine paid, on-the-job training with formal classroom instruction, often leading to recognized credentials. It ensures the skills learned are perfectly aligned with the company's specific technologies and needs. They're essentially growing their own future workforce.
So pulling all this together, the global drivers, the AGI potential, the skills gap, these training models, the ultimate message from these sources seems pretty clear for anyone in leadership, whether in government or business.
It feels like a mandate, really. There needs to be a decisive pivot. Resources, focus, political capital. It needs to shift away from trying to protect jobs or industries that are inevitably being transformed by technology.
Towards what?
Towards aggressive, proactive talent creation. We know the old tasks are declining. We know the new tasks require different skills. The only way to navigate this transition successfully, to avoid massive unemployment or crippling skill shortages, is to build the most effective, accessible, and rapid reskilling systems possible.
The nation or the company that figures out how to build that engine for reskilling most effectively
is likely the one that leads the next industrial era. The technological change is happening. The question is how well we prepare our people for it. #outro.
So let's wrap up this deep dive on the Great Retasking. We started by questioning that stark image of the dark factory.
Yeah, finding the current reality is much more light sparse, with humans still playing absolutely critical roles, especially where complexity and adaptability are needed.
We saw how the impact of automation is really shaped by unique national circumstances. In the U.S., it's often a patch for labor scarcity.
While in China, it's wielded more like a strategic tool for global competitiveness, leading to that dual effect of displacement and polarization.
And in Japan, it's a demographic imperative, almost a survival mechanism, making automation and labor complements.
Then we looked ahead to the potential convergence with AGI post-2030. That could shatter the complexity barrier, enabling truly autonomous factories.
But it comes with that enormous multi-trillion-dollar CapEx hurdle and the risk of an AGI divide between giant firms and everyone else.
Which forces that choice between pure replacement automation and the more collaborative, human-centric vision of Industry 5.0.
And underlying all of this is the shift to the new-collar workforce. We know that old repetitive jobs are declining.
We know the new jobs, the technicians, the integrators, the analysts working with the technology are higher skilled, higher value, and potentially higher paying.
But the massive skills gap looms large. Millions of unfilled jobs projected simply because we aren't training people fast enough for these new roles.
Which brings us to our final thought, something for you to consider. We know AGI and advanced automation are coming. We know the nature of work is changing profoundly. We even have models, like Singapore's Skills Future or those industry partnerships, showing that large-scale reskilling is possible.
So the provocative question is this. Given the urgency, what's the real human cost of the delay? What happens to the millions of people caught in that gap between the accelerating pace of technology and the often lagging pace of our educational and policy responses?
Who bears the brunt of that transition period before we truly solve the reskilling challenge? What's the price of that skills gap? And ultimately, who pays it?
Something to think about. Until our next deep dive, keep digging deeper.